Okay, so let's pop into our code and see what we've already got done. We have imported our pandas library and the model we want to use to train our data. We have gone through, read our data. We have gone through, split it into training and test data. We have trained our model, and we've even tested our model by passing in a set of test data. Now, when we were done this, you might have actually noticed when we were comparing the results of our predicted and actual values that when you actually display the values that were predicted by the model and compare that to the values that were in the actual values for the test data, that they displayed differently. And I'm guessing some of you out there were like, I wonder why those are showing up differently. There is a reason for it, because these two objects are not actually the same type. If you take a closer look, and we can use the type method to ask for the data type of an object, very useful anytime you're not sure what you're working with. If you look at the type of yPredict, it says it's a NumPy array, whereas yTest is a pandas data frame. Now, up until now, we've been very focused on working with pandas data frames. So what is this NumPy array thing? It's very similar to a data frame, and it's got a lot of similarities, but its functionality is not the same. They are actually different classes. So what does this mean in terms of our code? Well, it means if we try and do something like call the head function to display the first few rows of the array, well, that's actually going to fail because NumPy arrays do not support that method. That's a data frame method. So it's not available on the NumPy array class. So let's just take a little closer look at these. So the NumPy library in general, just so you know, it's basically a library that's designed for mathematical calculations and matrix calculations. So since it does matrix calculations, it has to support arrays. And a one-dimensional NumPy array is very similar to creating a series in Panda. So if you look at the code, it's very similar to create an array versus series, but really only the big difference is I'm using a different constructor, the array constructor versus the pandas series constructor. But aside from that, all the syntax is the same, except that they do have slightly different functionality. If you want a two-dimensional array, which we do with the data frame in pandas, you can create a two-dimensional array using a NumPy array. And you'll see it come back. And again, very similar to what we have with a pandas data frame. The biggest difference between the two really is when you're working with pandas, the index is explicit. You see the index numbers displayed. Each row does have an implicit index when you're working with NumPy arrays, but it's not displayed when you're printing out the values. But you can still use it to reference a particular row. For example, up here, when I was querying my series, I said, give me the value that's with row index number 2, which is Narita. Well, you can see in the pandas series that row index number 2 goes with Narita. That same index value is implicitly there for the array. It's just not displayed. So one of the biggest differences is that implicit versus explicit index. That does allow some extra functionality with pandas data frames when you get further into them. And when you have an array, again, two-dimensional, you can still specify by index position the row column position of the particular value you want to return, just like you can using iloc on a data frame. The difference again here being these are explicit index positions with a data frame. They're implicit on a NumPy array. There might be times where you want that functionality of a data frame. Maybe you want to call the head function, or you want to call the tail function, or maybe you have data in a NumPy array in a data frame and you want to take a column from one and move it to the other. You're going to get errors if you try to merge together a pandas data frame and a NumPy array, a column from one and the other. You're going to get errors if you try to call head or tail on a NumPy array. So there might be times when you need to move it from one to the other. So there's lots of different methods you can use to switch something from being a NumPy array to becoming a pandas data frame, or to change a pandas data frame into a NumPy array, and so on. I won't go through all of them, but I'll just give you one nice little example. If you want to convert our predicted values into a data frame, you just pass that NumPy array into the pandas data frame constructor, and it will create a data frame for you. So now I can actually have that same wonderful functionality of the pandas data frame on my predicted values. So you're going to end up going back and forth a lot between NumPy objects and pandas objects. So just be prepared. When that happens, you can use type to figure out what they are, and there's lots of great methods out there that'll let you switch back and forth between NumPy and pandas.